All right, math minions. I told you I would make a video of me going over the review. For those of you that hadn't joined the tutoring sessions, that's fine. I'll have this posted, and I'll probably take it down before the test anyway. So make sure you have worked on that review, and let's get to it. All right, so first thing we need to make sure we do is transformations. Again, that's been a part of every test that we've done. All the same transformations cause the same changes to the graph. So we got to be able to go both directions. I'll be able to give you two equations, you tell me the transformations, or I give you a parent equation and transformations, and then you give me the new equation. Okay, so if we want to go from, let's say, a log base 3 of x to log base 3 of x plus 3, that plus 3 should make it go up 3. Okay, that should make it go up 3. Now remember what a log looks like. If I want to do log base 3 of x, I can do it in Desmos, or I can do it in my TI. Let's do it in Desmos. Just to remind you where to get all that stuff, hit your functions button and go to the miscellaneous column, and here's your log base. Okay, so you want to go log base 3 of x, there it is, and if we want to do plus 3, we type in plus 3, it shifts it up 3. Okay, notice that the domain is still from 0 to infinity. It's not negative infinity, no negatives over here. 0 to infinity, it's the range that is negative infinity to positive infinity, and it has a vertical asymptote at x equals 0. Okay, so domain range, domain 0 to infinity, range negative infinity to positive infinity, and x equals 0 is the asymptote. Okay, look at the next one here. What if I put a negative in front? Remember, a negative in front is a reflect across the x-axis. Okay, so it flips it vertically. And minus 2 on the inside. Remember, if I subtract 2 from the x, that's going to make it go to the right 2. So you got to make sure when is it up and down, what is it left and right. This minus 2 is in the parentheses, so that is a shift to the right. If it were a plus, that would be a shift to the left. Okay. Now, if I shift it to the right 2, if the vertical asymptote is at x equals 0 and I shift it to the right 2, now the vertical asymptote is at x equals 2. So my domain will go from 2 to infinity. My range will still be from negative infinity to positive infinity, and my asymptote will now be at x equals positive 2. Okay, now this right here, this is an important one. Okay, if I go from log base 2 to 2 to the x power, the transformation is that it reflects across y equals x, because it's an inverse. Inverse is not a transformation. Because it's inverse, meaning that it's going to now reflect across y equals x. I know a lot of you on your assignment put y-axis. I don't know if you guys were just getting that from somebody else or just weren't thinking or paying attention to it. When you go inverses, it is a reflect across y equals x. Okay, so that means that the domain and range switch. Again, from this one now, the domain would be from negative infinity to positive infinity, because that's exponential now. Exponential is negative infinity to positive infinity for the domain, and then the range is from 0 to infinity, and it switches to a y equals horizontal asymptote. Okay, so make sure you are paying attention to our different transformations that we can do. Again, that should not be new. That should be pretty easy. All right. Next, rewrite the log function as exponential functions. We want to change forms. We have log form. We want to put it into exponential form. Again, I'll remind you how that works. That we have an exponential. Then we can rearrange it to say the base stays the same and logs equal the exponent. Okay. Now, I like to tell you that you're going to undo the log. Remember, natural log is log base e. So you're going to undo that by using an exponential base e. And that cancels out, so you end up with e to the 12th equals a as your exponential form. Again, we're going to take this and we're just going to change forms. If I look at this one, what's the base? The base is a 7. Logs equal the exponent. So this will be 7 to the x power equals 65. In other words, you have a log base, you use an exponential base to undo it. And so you end up with 65 equals 7 to the x, or 7 to the x equals 65. Log bases get changed to exponential bases. Again, the base stays the same and the logs equal the exponent. Or we could say 2 to this power equals 2 to this power, and then the exponential base will cancel out the log base, and you end up with 32 is equal to 2 to the 5th. Okay, do you remember what the base is if you don't see one on a log? If they don't tell you what the base is, it's understood to be base 10. So if we want to change forms, we use 10 to this power equals 10 to this power. The log base and the exponential base cancel out, and you end up with 10 to the b equals a. Okay, these are not particular numbers, but you should be able to rearrange them. Now we need to go the other direction. Now I have an exponential function that I want to turn into a log function. Okay, so same process. If I have a exponential, I can turn it into a log, or vice versa. And you can just remember the order that they go, that logs, the base stays the same, and logs equal the exponent. The base stays the same, so that would be a log base 3 of 81 equals 4. Or you can do the inverse, and that's, again, same thing up here. Exponential bases undo log bases, so log bases undo exponential bases. So you can use a log base 3 to undo this exponential base 3, and you have log base 3 of 81 equals 4. Okay, do the same thing here. This is an exponential base 12. You can use a log base 12. This is the same stuff we've been doing when we've been solving, but now we're just talking about rearranging. So you need to be able to rearrange things tomorrow. Exponential bases undo log bases, so log bases can undo exponential bases. And whatever you do to one side, you do to the other. Okay, so here, what would be the log base that we use? It would be log base 64. Okay, that'll cancel this out, but then I have to do log base 64 on this side too. So I end up with log base 64 of 8 equals a half. Okay, here, what if I have an e? Well, I can do log base e, but I can also do, remember, instead of just log base e, I also can call that the natural log. Okay, very rarely, even though we're doing log base e to cancel out an exponential base e, very rarely will you see it written as log base e, and in fact, if it's a multiple choice question, you won't see log base e as an answer. You will see natural log. Okay, so then this one we would say natural log of s equals r. If you've been paying attention, you've been doing the assignments, this should be a piece of cake for you. All right, now we use our laws of logs to expand and then to condense. So real quick recap. Let me put my laws right here. My laws of logs. The first law says that if you are multiplying logs, then you can expand that to addition, where everything gets its own log. If you are dividing logs, then the 1 in the denominator can expand out and get its own log, but you would give it a negative log. Division expands to subtraction. And again, the important thing is whatever was in the denominator gets a negative log. That applies if there's multiple things in a denominator, they each get a negative log. And then the last one was that if you have a log of something with an exponent, you can move that exponent out front and make it a coefficient. Okay, so we're going to use those in expanding and condensing. So the first thing is I'm going to give everything here a log base 2. Log base 2 of a to the 4th, and then a log base 2 of b. Okay, and because they are multiplying, they get addition. So the last thing will be that I'm going to use that last law at the bottom down here and make the exponent become a coefficient. So it's log base 4 of a, log base 2 rather, of a plus log base 2 of b. Okay? All right, let's go to the next one here. Again, here's a division. We're going to division is going to expand to subtraction. Everything gets its own log, log base 7 of x, and then log base 7 of 3. But the 3 is in the denominator, so it gets a negative log. Okay, now same thing with this one. Everything gets its own log, even the 7. So the 7 gets its own log. The x to the third gets its own log. The y gets its own log. The z gets its own log. Okay, now the next thing I'm going to do is to tell you that remember these are on the numerator, so both the 7 and the x to the third get positive logs, but both of these in the denominator, both of them get negative logs, not just the y, even though there's multiplication happening, it's happening in the denominator. And then the last thing would be move the exponents out front, but only of the log that they're in. Okay, so then this would be log of 7 plus 3 log x minus log y minus 2 log z. Okay, next, split these up. They both get their own log and they are multiplying. So they are going to get positives. Now, you have to remember one other thing here, and that is that if you have a square root, we need to turn it to a 1/2 power. So in reality, I should be writing plus log of y to the 1/2 power. Okay, that's something you're going to remember tomorrow. I'm going to throw some square roots at you in these questions. I'm just giving you a heads up. So you need to be able to write that as an exponent so that when you expand it, you move it out front. So this would be log base 2 of x plus 1/2 log base 2 of y. Okay. All right, let's use the laws now, these same laws that we've been talking about. Let's use them now to condense. So if I have a bunch of things that all have log, I want to condense it down to just one log. So I want to go the other direction for this. Okay, so first, take care of this rule. Take any coefficients and make them exponents. Again, that's kind of working our way backwards here. So this becomes an exponent, this becomes an exponent. And then we write one log. So this is natural log of 4 plus natural log of x to the third plus natural log of x to the fourth plus 5 squared. We're going to take now one log and use our rule that says if you are adding, you can condense it down to just one multiplication. So 4x to the third, x to the fourth plus 5 squared. I know that looks weird, but we're condensing this all into one log where we're multiplying all of these pieces together. Okay. All right, let's do the same thing with the next one. Okay, we get multiple things that have log on them. We want to condense it down to one log. So the negative tells us that if we're subtracting, we condense it into division. So this goes down to log of, and then we add x squared minus 9 over x plus 3. Okay, next one, same thing. Same thing, we want to condense it. And I know it looks complicated. It looks like there's a lot in here. There are 1, 2, 3, 4 different of these log base 6s that eventually we want to be able to write log base 6 one time. Okay, so we need to keep track of, before we do anything else, take any numbers that are in front. Since we just want log base 6, let's move any numbers in front up to exponents so that everything is just log base 6. Okay, so we end up with log base 6 of x squared plus log base 6 of y to the 1/2 power minus log base 6 of 2 minus log base 6 of z to the third power. Okay, now you remember what we talked about, that 1/2 power? That 1/2 power is really a square root, and so we are going to have a square root of y right here. Let's just call that square root y right now. And then all the positive ones go in the numerator, and any negative ones mean they go in the denominator. So positive logs, I'm going to put that and my y, a square root of y, up in the numerator because they came from positive logs. And then the 2 and the z to the third go in the denominator because they came from negative logs. And I've condensed it down to just one log. Okay? Again, those are laws of logs. You can have a couple of those tomorrow on the test. Now, let's get to the solving. Here's where we're going to need our calculator or Desmos, either one. I should have my calculators back by tomorrow. But I'll show these with Desmos, again, for the benefit of everybody else that needs to be able to use Desmos. Okay, again, what we're using is the fact that log bases undo exponential bases, and log base will undo an exponential base, and an exponential base will undo a log base because they're inverses. Okay, those are going to be the two things we're going to use. So if we want to solve for x, we look at this one. I've got x up in the numerator. Okay, that means I need to undo this 3. Okay, can we divide by 3? I hope you said no, because the 3 is an exponential base. So to undo the 3, we need to use a log base 3. And we're going to do it to both sides because, again, that's our rules about solving. Whatever I do to one side, I do to the other. So this will give me 4x equals log base 3 of 7. Okay? I need to go calculate log base 3 of 7, figure out what that is, but then I need to divide that answer by 4 to finish this thing up. Okay? And so let's go do that. Remember, we get our, let's clear this out. We're going to do log base 3 of 7. Okay, that would be that decimal, but we're not done because we wanted to take that number and divide by 4 to finish off our calculation. So 3 decimal places would put it right there, and the 8 is going to tell us to round that 2 up. Okay, so it would be 0.443. 0.443. Remember, we can test our answers, and if you run into a multiple choice question, this might be a good strategy. You can test. If I plug in that 3, that answer there, 0.443, up here is an exponent, 4 times that, and make that the exponent of 3, I should get 7. If I don't, something went wrong. Okay, now we got another exponential one. I've got e to this power. How do I undo an exponential base? I use a log base. Now remember, log base e is the same thing as natural log, but in terms for calculation purposes, you can use either one. Okay, so that's going to give me 4x minus 2 equals whatever natural log of 100 is. Okay, let's go get that. Natural log of 100. Okay, again, you can use log base e, or you can just use natural log for this one. Okay. All right, let's see. Natural log of 100, 4.605. Let's go put that in there. So 4x minus 2 equals 4.605. Then we're going to subtract, add 2 to this one. So 4x equals 6.605. Then we're going to divide by 4. So we're going to take our 6.605 divided by 4. 6.605 divided by 4. So 1.651. More likely on these fill in the blank ones, you are going to have to go to 3 decimal places on the test. Okay, here's another one with x in the exponent. Okay, but what's the base? The base is just the part that is the exponent. So that is just the base. The 1.9 is the base. Let's just say that that's the base, which means I don't need the 250. This is the one that people mess up on. They want to deal with that 250. No, the base has this exponent on it. So we want to get rid of that exponent by dividing by 250. Get rid of that 250, but divide by 250 here. And we got 1.09 to the 5t power equals 500 divided by 250 is 2. Now we have an exponential base. How do we undo an exponential base? Use a log base. Oh no, it's got a weird decimal. So what? It's the base. Use a log base. Even though that exponential base is a decimal, use a log base to undo it. So we're going to do log base 1.09 of 2 on this side. So 5t equals log base 1.09 of 2. And then we're going to finish off our calculation by having to divide by 5. I'm just trying to save some time and type it all in or write it up right here. So that's what I need to go calculate. Now let me do it in my calculator, just cause. Okay. Those of you that would like to use the TIs that show up in person, you certainly could. You remember, you get your log base by hitting math and going up a couple times. So we want log base 1.09 of 2. And that gives us a number that we need to now divide by 5 to finish off our calculation and solve. So in this case, t would equal 1.609. Okay. All right, let's go to the next one. Well, now x is not an exponent. Now x inside of a log. Remember, natural log is the same thing as log base e. So whichever way you see it. Okay, now, before we get to undoing that, we need to get rid of that minus 4. Okay, just like over here, we had to undo the 250 because it wasn't part of the base. Same thing here. The minus 4 is not part of this log. It's not in the parentheses. So I'm going to have to do plus 4. So I've got e, I've got log base e or natural log, either way. That's what natural log is log base e equals 6. Now I've got a log base. A log base will undo an exponential base. An exponential base will undo a log base. So now I do e to this power equals e to this power, and there's my answer. X equals e to the 6th power. Now if I want to go figure out what that is, again, I can pull up Desmos or I can pull up my TI and I can just go type in e. There's e, and then I hit that button for my exponent, e to the 6th power, 403.429. 403.429. Okay, so approximately 403.429. If I'm having to round that to 3 decimal places, that's what I would be typing in. If it's a multiple choice problem and that is an answer choice, pick it. It is true. It is e to the 6th. All right, getting there. Almost done. All right, now we're back to having x as an exponent. There's nothing extra for me to get rid of. I cannot get to that plus 1 until I get rid of that exponential base, and this is no longer in any exponent. So again, remember, a log base will undo an exponential base. What's the base? 9. So log base 9 to this side, log base 9 to this side. Okay, so I have x plus 1 equals whatever log base 9 of 6 is. Okay, so let's go figure that out. Let me use my TI this time. Again, I want to do log base 9. Pull it over here so it just shows up. I'm going to do log base 9, so hit math, and then go up a couple, hit log base 9 of 6 is that number, and then I want to subtract 1 from it, from whatever that is, so just hit minus 1 to that. I think it typed in something there, but I want to do it here. Minus 1 to that answer, and I get negative x equals negative 0.185. Okay. All right, let's do this last couple here. Now, the last couple, you notice that the x is in parentheses with something else. All right. The x is in the parentheses with something else. That means I can't get to this plus 10 yet. I can't undo it. It's in the parentheses. It's in the log. Again, so here we have another log. What's the base? It's a base 10. When there is no base listed, it's base 10, which means, again, if we want to undo a log base, an exponential base will undo a log base. So I'm going to do, let's go green, 10 to this power equals 10 to this power. So I end up with 5x plus 10 equals 10 to the 3rd power. 10 to the 3rd power should be 1,000. So minus 10, you get 5x equals 990. I'll just divide real quick, 990 divided by 5, 990 divided by 5, 198. Okay, last one, getting up there. Again, x is in this log, so I can't get to it yet. I do need to get rid of that 2 first, so divide by 2, and I have log base 2 of 5 minus x equals 2. How do I undo a log base? That's right, use an exponential base. So here's what I have. 5 minus x equals 2 to the second power. 2 to the second power is 4. Okay, minus 5 next, minus 5. Now don't forget, this is negative x. We didn't get rid of that minus sign. All we did was get rid of the 5. And that's negative 1. And if negative x equals negative 1, then x equals positive 1. All right, that's your test review.